Hey everybody, welcome back to Algebra 1 videos. And in today's videos, we're going to go through solving inequalities with variables on one side as well as both sides. So in the last video, we covered a little bit about what inequalities are, and I'm going to show you how to solve them. So really quick thing at the bottom here, just keep in mind that the steps for solving inequalities are the steps for solving equations. All that's changing is the sign, so you just have to consider that, right? So, you'll isolate your x values, isolate your x plus your coefficient, and then you will solve for x. So let's start off with the first problem. The ones on the left-hand side are going to be equations or inequalities with variables on one side. So how do we do this? Well, first we'll move the 9 to the other side. So we'll just subtract 9 from both sides. And what do we get? Well, 5 minus 9 gets you negative 4. Negative 4 is greater than or equal to 3x. Now you divide both sides by 3 to get rid of that coefficient. And you get negative 4 over 3 is greater than or equal to x. So if this was an equal sign, you'd have a negative 4/3 is equal to x, but it's just a greater than or equal to. So you keep that sign there. That's all that's changed. So moving on to the second problem, well, we want to get our x by itself. So once again, subtract 9 from both sides, and 6 minus 9 is negative 3, so we get 7x is equal to negative 3. Now we're going to divide both sides by 7 instead, and our final answer becomes x equals negative 7 over 3. Or sorry, keep that in mind actually, I made that exact mistake. So x should be greater than or equal to negative 7 over 3, which means that any x solution to this equation will be a solution as long as it's greater than negative 7 over 3. For example, negative 2 works here, negative 1 works here, 0 works here, and so on. So in the last one, there's going to be a slight twist. Let's actually change up the signs. So this is going to be your equation. Negative 8x is greater than or equal to 8. So this would be a positive 8. So we'll divide both by negative 8. And we get x is greater than or equal to negative 1, right? Well, here's the catch. Whenever you divide by a negative number when using inequalities, the sign changes. Or to be exact, it just switches to opposites. So x greater than or equal to negative 1 becomes x is less than or equal to negative 1. So this becomes your final answer for the equation. And if you want to, you can plug it into your equation and check. If x is negative 2, negative 8 times negative 2 is 16, which is greater than or equal to 8. But if it's greater than negative 1, if we use this as our solution, what do we get? Well, x is greater than or equal to 1, so negative 1. So plug in 0. If x is 0, you get 0 is greater than or equal to 8, which is actually wrong. So just keep that in mind. Whenever you see a negative, switch the sign. So if you see, I'll just note that down here for you guys. If you divide, to be exact, not just see, if you divide by a negative sign, the inequality will also change signs. So changes signs. So now we're going to move on to solving inequalities with the variables on both sides. Once again, that process will still repeat, but we're just going to keep those signs there. So we'll subtract 5 from both sides, and ironically here, 5 cancels out, and we get 3x is greater than or equal to 6x. So, divide both sides by 3 to isolate for x, and you get x is greater than or equal to 2x. Now, once again, you can divide by x in this case, because there's an x on both sides. So you get 1 is greater than or equal to 2. So actually, this has no solution because that is a false statement. So this equation has no solution. Now, moving on to the second equation, let's actually move the 7 to this side. Or let's move the 4 over here instead. So moving the 4 over here, we get 2x is less than or equal to x. Now this should be minus 4, so x plus 3. Now move our x over here, and we get x is less than or equal to positive 3. This becomes our final answer for question 2. Now for our final question today, we have a negative x here, so we actually have to add x when we move it over here. And we get 10 plus 2x is greater than or equal to actually -5, and we'll move the 10 over here. So you subtract by 5, and you get 2x is greater than or equal to, well, -5 minus 10 gets you -15. Now divide both sides by 2, and you get x is greater than or equal to -15 over 2. So keep in mind that when you divide the x, so if you divide your variable, if you divide the x variable by a negative number, that is the only scenario in which it switches signs. If you're dividing some random coefficient by a negative, it's not going to switch signs unless you still divide the x by that negative number. So that's just a tip when solving inequalities. Excuse me. So in the next video, this will most likely be the final 1 or 2 videos for inequalities. We're going to learn how to graph and solve inequalities, and we're going to work on more complex inequalities.